Hello and welcome to a new video. This is for Algebra 1. We are factoring polynomials again, so this is part 3, and this is going to wrap up our look at factoring polynomials, so if that makes you happy that it's at least the last one, then cool. And in fact, this will be the last of my polynomial lessons for right now, and yeah, let's get excited. This is going to talk about special cases as well as basically combining methods and maybe just like trying to decide how to factor if you're just given factoring problems. Let's warm up. So these are both factoring problems that we've seen before in the previous two lessons. So A is actually asking us to factor. It doesn't say how, but what we would do is look for the greatest common factor. And the way I know that this is something I should do is when I look at this, I notice they're all divisible by 2. I also notice they all have at least one x. We have x cubed, x squared, and x, so each of those has an x inside of it. So what we're going to do is take out what they have in common, which is 2x. And the way we write this, remember, is we say, okay, the thing they have in common goes outside my parentheses, and then inside the parentheses, I put what happens after I divide each of these by 2x. So as we're dividing these, we divide the numbers, and then we think about how the x's will be affected by dividing by an x. So 4 divided by 2 is 2. X cubed over x cancels out an x and leaves us with x squared. And then we keep going. 2x squared over 2x, the 2's cancel, an x cancels, and it leaves us with 1x, or just x. And then 10x divided by 2x, the x's cancel out since they're both just regular x's, and then 10 divided by 2 is 5. So this is our answer. One of the things we're going to be looking at today is the fact that if we're asked to factor, we should be checking to see if this also factors. In this case, it doesn't, and I can notice that by doing a quick check of 2 times 5, which is 10. Is there anything that multiplies together to get 10 that adds to get this middle number, which would be 1? And there's not. So this is the answer because we can't factor further. That's one of the things we're going to be looking at today. The second one here is a quadratic trinomial. It doesn't have anything in common. There's not a number in common. There's not an x in common. And so if we can factor this, it factors into 2 parentheses. Now, this was what we did last lesson. I gave 4 different ways that we could do this. Guess and check, box method, slide and divide, and split the middle term. And it's my hope that if you did that lesson, you picked which way was your favorite. And so I'm going to choose to use, I may alternate between box method and slide and divide because those are my 2 favorites. And if you have a different favorite, then hopefully they're similar enough, right, that you can still kind of follow along. So I'll do the box method on this, which means first I start off by drawing a box. Once I have that box, I make more boxes so that I have 4 boxes. Then I take the first term and put it in the top left, the last term and put it in the bottom right. And then I say, okay, what is 2 times 6? That's 12. What numbers multiply to get 12 and add to get 7? So there's actually 12 has a number of factors. For being such a small number, 12 has quite a few factors. 1 and 12 does not add to get 7. 2 and 6, close, but no. 3 and 4 is correct. So what we do is we put an x with those numbers and we put them in these 2 spots. It doesn't matter which one you put where, but if you're working through it with me, it might be easier if you go ahead and put it in the same spot as me, just so you don't get confused by location. Then what we do is this is a like reverse Punnett square situation where we're looking for what do we have in common with like the stuff that's on the left. So 2x squared and 4x, they have a 2x in common. So I write 2x up here. And then the 3x and the 6 have a 3 in common. I look at the top and say, well, those just have an x in common. And I can double check that I'm on the right track by saying, well, 2x and x do make 2x squared. And then 3 and x do make 3x, right? And then I look at the bottom 2 and say, okay, those both are divisible by 2. They don't both have an x, so it's just 2. And then we put plus signs here and here because there aren't any negatives to worry about. And so our 2 parentheses are 2x plus 3 and x plus 2. So that's the box method. Slide and divide would do similar things. It's just a different way to kind of represent it that you might like better. And if that's the case, then cool. Basically, it just changes the way we look. We, instead of just multiplying 2 and 6 together, we actually slide away the 2 and turn this number into 12. We do the exact same thing that we did earlier where we say, well, multiplies to get 12 and adds to get 7, which is 3 and 4. But then we have to divide both of these by the number we slid earlier, that 2 that's in front. And what that does is it lets us move the 2 whenever it doesn't simplify and go away, but 4 over 2 is 2. So we simplify that and see how we got the same thing both ways. That's, me doing those 2 ways right next to each other. If you haven't already decided which way you like better, you really should just go ahead and decide and then try to stick with that method. Because, by the way, factoring is something that's going to keep coming up. So if you're in Algebra 1 and you're just learning factoring, I don't know if any of you've ever done this. I definitely remember doing this sometimes in math where you're like, this probably isn't important, so I'm not really gonna worry about learning it. Almost every time I did that, I feel like it ended up being super important. Factoring, I can tell you, is something that may come up in geometry and will definitely come up again in Algebra 2. And if you go further, it's just going to keep being there. The higher we go, the more unexpected, I guess it is in some ways, that if you're in calculus, you'll be doing a calculus-y thing and then all of a sudden, bam, you were supposed to factor. So it really, if it can become kind of second nature to you sometime over the next couple of years, that would be really, really helpful for you. So let's look at some problems here. So these first 2 examples are some special cases for us. So you might notice that this looks a little different than some of them we've done because it is quadratic. We do have an x squared. We only have 2 terms. We don't have 3. So before now, if we only had 2 terms, we pretty much just did greatest common factor. But we don't have anything in common here, so we can't do greatest common factor. What are our other options? Or just because this doesn't have 3 terms, could we actually think of it like it has 3 terms? Because just because there isn't an x doesn't mean we couldn't pretend there's an x. But in order to pretend like there's an x there, we need to say, well, there's 0 x's. And that might seem weird because why would we write there's 0 x's? It's just so that we have this correct perspective of this does in fact factor into 2 parentheses. And the way we figure out what numbers are going to work is by saying what multiplies to get negative 25 and adds to get 0, because when we FOIL, right, when we do outer and inner terms, this is saying that when I do those and add them together, they cancel each other out. So what numbers will make that work? Well, 25 only has a couple of factors, 1 and 25 and 5 and 5. And since it's negative 25, one of those needs to be negative, which is good. That's how we're going to end up doing 5 minus 5, which gives us 0. So one of these needs a plus 5, one needs a minus 5. Again, it doesn't matter which order you do it, just one has a plus and one has a minus. Now I want us to notice some connections here because that was actually pretty easy once we realized that what we're trying to add to is 0. But if I look at B as far as trying to factor it the normal way, it's actually pretty tough. If I wanted to try to factor B by saying, okay, let me slide and divide, or let me use the box method, well, I'm going to have to do 16 times 49 and then try to find the factors of that large number that will subtract to get 0. There's actually an easier way. Anytime you have 2 terms with a minus in the middle, that both of those terms have something that you can find, both of these terms are perfect squares, which means you can square root them and get a nice answer, then it follows this pattern of the same thing twice, but one has a plus and one has a minus. And the way you know what terms should go in there is actually by square rooting. If I square root 16x squared, I get 4x. So if you haven't already thought about this, the square root of x squared is x, in the same way that saying the square root of 4 squared, which 4 squared is 16, is 4. Square roots and squareds actually undo each other. So the square root of 16x squared is 4x. The square root of 49 is 7. So because both of those have square roots and because there's a minus sign in the middle, I can know without having to do any of our other methods that this is 4x plus 7 and 4x minus 7. This is such a kind of big deal. It ends up coming up actually fairly often that it has a name. We call this the difference of two squares. And so what that's referring to is the fact that we have two perfect squares. We have two things we can take the square root of, and difference means subtraction. So anytime you see two things subtracted that you can square root, you can immediately put it into two parentheses in this way. Now you may be thinking, well, wait, it says difference. What if it instead had a plus? So let's think about x squared plus 25. How would that factor? Well, and if you're following along with me or in my class, we haven't actually really had any that didn't factor. But that is technically an option. Anytime you're doing factoring problems, it is possible that something might not factor. And in this case, that's what's happening. Because think, can you multiply to get 25, but add to get 0 if everything is supposed to be positive, or if both numbers are supposed to be negative? No, the only way to take two numbers that multiply to get 25 and have them end up being 0 is for them to be a plus 5 and a minus 5, but those multiply to get negative 25. So I don't know. I think it's really cool. If you have two terms, your options are either greatest common factor or difference of two squares. If you have a plus in the middle, it doesn't factor unless you can just take a greatest common factor out. So that's our first kind of special case. Here's our second kind of special case. And in both of these special cases, you technically don't need to realize they're special cases. You can factor them the way we've been doing it. It's just that whereas on A here, this is actually pretty easy to factor without using a pattern, B is much trickier just because our numbers are bigger, okay? So this is really supposed to be like a time save for us if we realize we can do it. So this is x squared minus 18x plus 81. So we need to figure out what multiplies to get 81 that adds to get negative 18, which would be negative 9 and negative 9. And since it's the same thing twice, we actually like to rewrite that as an x minus 9 with a squared on the outside. And so that would be our answer here. And what's happening is, again, we have perfect squares at work. And this is actually called a perfect square trinomial. Anytime we name things in math, that means they're important, right? So a perfect square trinomial is three terms that you can factor into something that is a perfect square. So x minus 9 squared, we'd call that a perfect square, even though it is like a polynomial. So how do I know it's a perfect square trinomial? I know that it's a perfect square trinomial if I can square root the first term and the last term, which in this case I can. I get x and I get 9, which is the two things in my parentheses. The tricky part of perfect square trinomials is this middle term. So the middle term has to end up being x times 9 times 2. And then it can be either positive or negative. Whether this is positive or negative is what makes the inside of our parentheses positive or negative. So in order for us to know that this is a perfect square trinomial, let's look at B. We need to be able to take the square root of each of these. So let's see, 25 has a square root, x squared has a square root, 9 has a square root. Okay, so far so good. We look at this and say, okay, this is a plus, so probably this factors into 5x plus 3 squared. Now I just said probably. We don't really like saying things like that in math. The other thing to check is this 30x. So in order for this to really factor into 5x plus 3, then 30x has to be whatever you get when you do 5x times 3 times 2. So 5x times 3 is 15x, times 2 is 30x. Yes, that worked. Now, why is that the case? When we FOIL 5x plus 3 times 5x plus 3, the first terms give us the 25x squared, the last terms give us 9, but the outer and inner terms both end up being 15x. And so when we add those 15x's together, we get 30x. That's going to happen to us every time we do a perfect square trinomial. And so this is a pattern that we hopefully will be able to start recognizing. So for problems like example 1 and example 2, you know to use this trick if the x squared term and the term without an x, if both of those have square roots. For example 2, these perfect square trinomials, you can have a minus in the middle or a plus in the middle, and that tells you whether or not your answer has a minus or a plus. And from there, it's just a matter of saying, okay, can I find the square root? If so, what is it? And putting it into the parentheses correctly. I think it's really interesting that when we start with 2 terms, we end up with 2 parentheses, but then when we start with 3 terms, we end up with 1 parentheses and a squared, because it feels kind of backwards, right? That's the case, but that's it. I do want to make a quick note that I feel like Algebra 1, a lot of people don't really grasp how nice these patterns are. It may even take you much longer to really get them. But I encourage you to try to be on the lookout for things that you can square root to see if these patterns work, because they will save you time. So on B, I didn't have to do 25 times 9 and use the box method or slide and divide because I recognized that they had square roots. The other thing that we're going to be doing in this lesson is just a whole lot of factoring where we're kind of combining methods. So these are both quadratic trinomials. Our goal is going to be to put them into 2 parentheses, but before we do this, we actually want to check for a greatest common factor. I'm going to do a separate video, I think, on kind of like how do you factor when you just are given something and told to factor. But basically our first step is always supposed to be to check for a greatest common factor, because it will help us get the right answer if we take out the greatest common factor first instead of trying to do things and then maybe notice a greatest common factor. And quick note, for slide and divide, if you don't take out the greatest common factor first, slide and divide does not work well. So definitely try to take out greatest common factors. So for instance, what can I divide each of these 3 numbers by? Definitely 2, definitely 3, so definitely 6. So I'm going to factor the 6 out of each of these, and that gives me x squared minus 9x plus 20. And then I'm going to ignore the 6 for now. It definitely needs to be in my answer here at the end, but for now I'm going to ignore it and say, well, does this part factor? Is there something I can multiply together to get 20 that adds to get negative 9? And there is. I'd use negative 4 and negative 5. It's an awkward gap here for my answer. Sorry about that. So my answer is that I have 6 times x minus 4 times x minus 5. And this may be a little bit confusing because the 6 is at the very front, and you may be like, I don't really know how that all works. Basically, we're saying that we multiply 3 things together and get our original problem, 6x squared minus 54x plus 120. The way you would check that is there's multiple ways you could do it, because you can do multiplication in whatever order you want. So we could choose to do the 2 parentheses together and then distribute the 6, or you could choose to distribute the 6 into one of those 2 parentheses and then FOIL. But when we have that 6 in front, it's not saying to times both of the parentheses by 6. That's actually not going to work. We could choose to do 6 into one or the other, or we could wait and distribute the 6 into after we've put the 2 parentheses together. That's if we're checking our answer. That's what we would do. So let's look at B, and you might get excited about B. I'm a little disappointed in myself for B because how many different ways could I say it? I have a 5 in common. That's great. And when I take out the 5, I end up with x squared minus 9x plus 20, which, whoops, that's the same thing we just did. So it's still x minus 4 times x minus 5, but this time there's a 5 in front because we took out the 5 that was in common. So whoopsie, my bad. Let's move on. Let's not linger on that too long. Example 4. So we have greatest common factor to look for again. That's our first thing. And then we're going to try to factor. Of note, after we took out our greatest common factor on these, we ended up with x squared that didn't have a number in front, which is why we were able to just go straight to parentheses. But remember, if we take out the greatest common factor and we still have a number in front of x squared, then we have to use guess and check, box method, or split the middle term to figure it out. And that's what's going to happen to us here. So 6, 38, and 12 are all divisible by 2. It's a sad day that we can't divide by 6, but we're gonna power through. I believe in you and me and us. Okay, so I take out the 2, and that leaves me with 3x squared plus 19x plus 6. Okay, now what? We're going to ignore the 2. It needs to be in our answer, but we're going to ignore it for now and say, how do I factor 3x squared plus 19x plus 6? So I'm going to use the box method. So that means I start with a box, and then I make another box. And if you're like, why do you keep using a funny voice for that? Well, maybe you'll remember it better, because maybe you'll have a funny voice in your head whenever you start doing it. I don't know. We got to say 3 times 6 is 18. What multiplies to get 18 that adds to get 19? It might take you a while to come up with this, but it's 18 and 1. Let's not forget that that's an option. So hopefully it wouldn't take you a while to get it, but our brains are so weird. They'll focus on the first set of factors we think of, and then they'll try to make it like impossible for us to think of anything else. It's very annoying, but we definitely all have that happen to us at some point. So let's look at what's in common. This would be 3x. There's nothing in common here on the right, so we're going to put a plus 1, because it's not really that there's nothing in common. They just have 1 in common. Let's look at these top 2. They have an x in common. Bottom 2, they have a 6 in common. And remember, you can double check that you're doing it right by basically doing a quick multiplication. 3x and x is 3x squared. 1 and 6 is 6. X and 1 is 1x. 3x and 6 is 18x. So this would be 3x plus 1 times x plus 6. And don't forget your 2 in front. Here is our answer. Voila! Let's try B. I don't think it's going to be the same as on the previous example where it ended up being the same parentheses. I'm pretty confident about that. Now, one of the things here is 224 is a big number. And so we might look at this and be like, I don't want to think of factors of 224. Well, let's look at and see if there's a greatest common factor. 2 definitely goes into all of them, but I believe 4 also does as well. Pretty confident about that. 4 goes in. And then 4 goes into 224 56 times. So here we go. If you're struggling because you have iffy multiplication facts, then my best suggestion for you is to use a calculator or multiplication like table to help you sum, just so that you get the hang of the factoring, and then try to basically use it less and less. It's more important, in my opinion, for you to practice factoring than to like sit here and be like, well, I don't know what goes into it. I give up. I don't know what goes into it. Well, pull out your calculator and try some things. And hopefully the more you do, the less you'll rely on your calculator. We need to do one of our 4 methods: guess and check, box method, slide and divide, split the middle term. If you don't know what I mean by any of those, that's the video right before this. I'll try to put the link in the description to help you find that if you are in need of it. So we need to say, what is 2 times negative 56? Ugh, that's negative 112. So we've got 1 and 112, 2 and 56. 3 does not go in. 4 and 28. I really think this is cool. If you have 2 and 56 and you realize 56 is even, well, you can take a 2 from 56, which turns it into 4, and say, well, what's 56 divided by 2? That's 28. That's how I do that so fast in my head. 5 doesn't go in, 6 doesn't go in, 7 doesn't go in. Wait, sorry, 7 does go in. So 7s are tricky. You basically would have to use your calculator or your brain to really quickly check to see if 7 goes in. It goes in 16 times, and that's what we need, because we can make one of these negative so that we can subtract and get negative 9x. Now we're ready for our box. Sometimes these problems are maybe all the time, these problems are annoying. It kind of depends on just like, in my opinion, some of this depends on how easy is it to find the factors. So if you're feeling that, I get it. That if it takes us a while to find the factors and then we still have to use the box after that, that is annoying. I'm with you there. So this left side has 2x in common. The right side has 7. The top here, these both have an x. The bottom, these both have a negative 8. So this is 4 times 2x plus 7 times x minus 8 for our answer. Thanks so much for watching. I hope that you'll press the thumbs up button and give me a like. And if you're not subscribed, you should subscribe because that way you'll know when I post more videos. And yeah, thanks for watching. Bye.